To successfully find the partial fraction decomposition of this fraction, you need to break up the denominator, namely factor it. X to the third minus 25x factors x times x squared minus 25, which factors further as x times x plus 5 times x minus 5. Okay, so notice, since we have three linear factors that are all prime, we're going to have constant a being divided by the first such factor, constant b being divided by the second factor, and then this third constant c being divided by the last linear factor. Linear because it has x to the first power, and they're prime because they cannot be factored any further. So it remains to solve for a, b, and c somehow. Now notice that if you multiply this equation by x to the third minus 25x, both sides of the equation would be multiplied by this denominator. The denominator here would be gone, and the only thing that remains would be the numerator. So essentially 4x squared minus 15x minus 125 is equal to the a being multiplied by these two factors and not its own denominator factor, because it gets cancelled out with this x, right? Because we said that both sides would be multiplied by x to the third minus 25x. So when you multiply that to the x's would be cancelled out, right? So a will multiply as a result with the other denominators that it did not have, right? Not the x. So the x will not be counted. So x plus 5 times x minus 5. So it's essentially this, right? X squared minus 25. Now the b will multiply the factors except its own, x and x minus 5. So essentially x times x minus 5 is x squared minus 5x. And then c will multiply the factors that it does not have, x and x plus 5. Multiply them together, you get x squared plus 5x. So now what you want to do, you want to align, you want to group basically your x squared coefficients first. Okay, so I'm going to bring the x squared forward, and I'm going to see what multiplies the x squared. I have a plus b plus c, right? All of these three multiply the x squared, as you can see. Now plus x, let's see what multiplies the x to the first power. Minus 5b, right? So we can put that down, minus 5b, and plus 5c, plus 5c. And then finally the constants, right? Minus 25a. So let's just put that down, minus 25a. And that's it, right? There's no other constant but that. So now what we're going to do, we're just going to match coefficients of the powers of x. So x squared, as you can see, 4 is on the left side, multiplying the x squared. The coefficient of the x squared is 4. On the right side, we already have a plus b plus c, so we can write that down, a plus b plus c. X to the first power has a negative 15 coefficient, and that is going to be minus 5b plus 5c. I'm going to align them here, minus 5b plus 5c. And finally, the constant, or x to the 0 power, is minus 125, and this is equal to minus 25a. Notice that this directly solves for a. If you divide both sides by negative 25, you get a is equal to 5. Okay, so we found the a value. Let's circle that. A is equal to 5 gives you b plus c on their own without the a. Right, so if this is equal to 5, then subtracting 5 gives you minus 1 on the left side is equal to b plus c. So minus 1 is equal to b plus c, and the second equation has minus 15 is equal to minus 5b plus 5c. Notice that we can also factor this further we can factor out the negative 5, right? So we will have a different system. B plus C, and then here we're going to factor out the negative 5. We're going to have B minus C. Dividing both sides by negative 5 in this equation gives us a new system that we can keep solving. So we're going to have the first equation is untouched. The second equation is revised. It is equal to 3 is equal to B minus C, right? Because these negative 5s are gone. So notice now, if you add both sides, you will have eliminated the C. And you will only have one constant to worry about, right? To solve for, which is B. So adding this side gives you 2, right? Negative 1 plus 3 is 2. B plus B is 2B. That solves for B, as you notice. Dividing both sides by 2 gives you 1. Right? So the B value is 1. That means, using this first equation, if B is 1, subtracting 1 gives you minus 2 for the C. Okay, so that's the third one. So now that we solve for this, we can find the partial fraction decomposition. So 5 over the x, because that's the A value, plus B is 1, so 1 over x plus 5, plus C is negative 2, right? So minus 2 over x minus 5. You have successfully found the partial fraction decomposition of the original loaded fraction. So I hope this was useful. Thanks for watching. See you in the next video.